Troubleshooting trunks and VTP. Trunking is your way of allowing VLANs to traverse between switches. Essentially, we configure VLANs on our switches and assign the specific ports to them, but whenever we want to allow them to bridge between switches, we configure a trunk, or what most other vendors in the world called a tagged port. I like the other vendor's word better because it's literally what happens. When you have a broadcast, let's just say in VLAN 2, it hits the switch, it first off checks and sees if there's any other ports in VLAN 2 to send it out, and then it says, oh, well, I've got a trunk with VLAN 2 as an added VLAN, so I'm going to send that across, but before I do, I'm going to add a little tag inside of that packet that identifies what VLAN that packet belongs to. So that way, when it gets to the other switch, it can unwrap it, if you will, because it takes that VLAN tag right off of it and says, oh, okay, this belongs to VLAN 2. I'll forward it right out any port that belongs inside of VLAN 2. So trunking by default allows all VLANs to go across and you throttle it down. Normally, other vendors of the world with tagging allow no VLANs to go across until you actually manually add each VLAN as a tagged interface, but that's other vendors. We don't care about them. We only care about Cisco. While we're talking about Cisco, let's also bring up the VLAN trunking protocol, Cisco's creation, and I have it here as an honorable mention because you do run into it here and there, but most people don't use it anymore because of the risk associated with it. VLAN trunking protocol should have been called the VLAN replication protocol because that's what it does. When I create VLAN 3 on this switch, it automatically replicates it to all the other switches that are part of the same VTP domain name automatically. Now, the reason it was called VLAN trunking protocol is it does that replication over trunk links. So VTP doesn't have anything to do with trunking itself. It just looks at the trunks and replicates all the created VLANs over there, so I don't have to create VLAN 3 on every single switch, and it keeps them in sync. And this is the danger associated with it. I delete VLAN 3 and it deletes it from all the other switches in the environment. Now, if you mistakenly did that, not thinking, you could take down an entire network, maybe VLAN 3 devices everywhere, immediately get completely disabled because literally the layer 2 fabric they were on, that VLAN 3, disappears. So what could possibly go wrong in this blissful trunking realm that we live in? Well, quite a bit. First off, you could have an encapsulation mismatch. And I would say this is probably more rare nowadays because ISL is fading into the sunset. But if you have this happen, essentially you're not going to be communicating across that trunk and you're not going to be given a status notification about it. I set this scenario up on Fast Ethernet. Let me do a quick show run. Interface Fast Ethernet 2/0/2. I set this guy up as a trunk on one side with .1Q, and then I telnetted into the other side. Let's do a show run interface Fast Ethernet 1/0/2, and I set it up for ISL. Now, what I wanted to show you here is I actually behind the scenes configured this and then started doing the up arrow on show CDP neighbors because you'll see right here before he saw this guy. So I'm looking at switch 2. From switch 1's perspective, this is switch 1 by the way. Switch 2 is sitting there on Fast Ethernet 1/0/2, and then there's 2/0/2. I do this mismatch in trunking encapsulation, and now you can see it literally disables from CDP. CDP can't show it anymore, and remember, trunking is a layer 2 thing. So essentially, CDP, which operates at layer 2, you're used to, like, no matter what, at least you can see in CDP, even if there's an IP address mismatch. Well, trunking even messes that up because the layer 2 encapsulation is not working. So the way you can tell this is happening, or at least give yourself a clue, is do a show interface trunk, right? When you do that, you'll see this is configured as a trunk, but you'll notice that on the VLANs that are allowed, 1 through 4094, it says allowed and active only VLAN 1, or essentially the native VLAN, is happening, the untagged VLAN, because it's like, hey, I'm not getting any kind of communication with the other side, so I don't know what trunks are happening over there, right? So you'll see them disappear from that allowed list. Of course, the fix for that is to go into whatever mismatch side you have and make sure you correct it. So we'll do encapsulation or energy-wise. I didn't even know that was out there. Switch port trunk encapsulation .1Q, right, on switch 1. And we should see in 2 shakes of a lamb's tail that show up correctly. Next thing that can happen is dynamic trunking protocol mismatch. DTP was another Cisco creation that allows you to auto-negotiate trunks, where these guys can talk to each other and be like, hey, you want to be a trunk? I want to be a trunk. Let's do this thing, and you end up with a trunk. Matter of fact, let me show you the setup on this switch. I'm going to do a show CDP neighbors. I actually cross-connected a bunch of ports. Let's just look at fast Ethernet 2/0/4. I'm going to do show interface fast Ethernet 2/0/4 switch port. Very handy command to see all this stuff. You can see the administrative mode. This is essentially what mode of DTP is it using. And I can see dynamic auto. Now, Cisco has gone through a variety of defaults. Most switches will actually have dynamic desirable as their default, where it's like, I want to be a trunk, please make me a trunk. They will keep trying to negotiate with the other side. Dynamic auto is like, hey, you know what? I'm cool with whatever. If you want to be an access port, I'll be an access port. If you want to be a trunk, I'll be a trunk. But I'm not going to try anything. So if you actually set both sides to auto, right? You're going to end up with I call it a mismatch, but maybe I should say a misconfiguration. I don't know. But essentially, auto is just going to sit and stare at each other until you flip one side to desirable, or you just go in there and do switch port mode trunk, and then it'll flip the other side from auto over into trunking mode. Now, we've got actually that scenario happening right here. Notice I've got dynamic auto, which was the default out of the box, but it ended up operating as a static access port. So let's do a quick show CDP neighbors again. I can see that this is actually connected to the other side, fast Ethernet 1/0/3. You're like, why didn't you match the ports up? I don't know. So I'm going to do a show interface fast Ethernet 1/0/3. Actually, my Ethernet, I couldn't bend them. I have really short Ethernet cables. Oh, wait, hang on. Switch port. And I can see this side is set up as dynamic auto, so it's staring there at a static access. So I'm going to go on this. Let's go into fast Ethernet 1/0/3. We'll do switch port mode dynamic desirable. I desire. So it's going to sit, and you can see immediately this side is like, whoa, going down, going back up. Why? Because when I hit the upper and do that same command, I can see that it has now flipped over to the trunk because the other side desires it. So you've got to have that matchup configured. Native VLAN mismatch, another common trunk misconfiguration. This one gets really ugly, actually. By default, you've got VLAN 1 going on, right? So if you ever change this to where I go in and do a switch port trunk native VLAN 20, let's just say. What that ends up doing is saying, okay, 20 will be the untagged VLAN. This side we left at 1. First off, if you've got CDP enabled, it's going to start detecting that. You've probably seen it before where it's like, hey, invalid native VLAN mismatch detected. It just continually floods your console port with messages that you've got a native VLAN mismatch on there. It's trying to warn you because literally what happens is when I try to pass traffic, let's just say from VLAN 20, instead of tagging it, it's actually going to strip the tag because it's the native VLAN, meaning the untagged VLAN. So what you've effectively done is bridged VLAN 20 into VLAN 1. Now in this case, that'll just cause these guys to really get messed up, to where they won't be able to talk to these guys because they effectively end up on VLAN 1. That's a bad thing. But what if you have sensitive stuff on VLAN 1? You just bridge these guys into, potentially your server VLAN or something like that. That could happen. It's rare, but it could happen to where you do that. But essentially, you bridge together whatever two VLANs you have marked as native. Now, likely the most common one from this entire list is this guy right here. And you'll want to know this because I can almost, it's like one of those, they're going to have this on the exam. You just know it. It's just one of those things that's so easy to do and so easy to hide and bury in some configuration somewhere that Cisco's going to have this. What this is where you say, hang on, let me just clear this off. On one side of the connection, actually, let me just bring it up. I'll show you the command. You go into the interface. Let's do 2/0/2, and we do switch port trunk allowed VLAN, and we say add, and we type in 1, 4, 5, or 6, 8, whatever VLANs you want to allow on that trunk, and then you forget to add them exactly the same on the other side. So essentially, one side not having that allowed to the trunk, VLAN 10 coming through, would pass here and then just get cut off when it reaches the other side because it's not an allowed VLAN. So the cool thing about this is they're going to have this on the exam as one of the buried in there kind of configurations. It's an easy one to find. You look at both sides, running configuration, you're like what's allowed on both sides, or you can even go in and do that same command I showed before. Did I show this command? Show interface trunk. All right. And that will actually tell you, hey, I've got, these are allowed and these are allowed and active. So if you trim that thing down, you'll actually be able to see, only those are allowed. Now, I know some of you are looking, you're like, well, wait a sec. Why? You said switch port trunk allowed VLAN add 1, 4, 6, and 8 because I had a moment of panic too. I was like, wait, I thought I trimmed that down. Well, I said add 1, 4, 6, and 8. Everything is added by default. Now, if I go in there, and by the way, this is a very common thing that people do that blows up the network. I'll do interface path 2/0/2. I do switch port trunk allowed VLAN, and then I just type in 1, 2, 4, or 4 and 8, or 7, or whatever my fingers type as I'm talking. Essentially, there's a big difference between just typing the VLAN list and typing in add in the VLAN list. Just typing the VLAN list replaces whatever was allowed with this new list. And a lot of bad mistakes have been made because people come in, they're like, oh yeah, I want to add in 50 or 60, and it replaces the list that was there before, right? So if I go back and do that same show command, show interface is trunk, you can see that the only thing that is allowed is 60 because it replaced that list. If I want to add 60, then put the word add in there. So that's how you can quickly verify allowed VLAN misconfigurations. Last thing on VTP. Again, the honorable mention. The beauty of VTP and the Achilles heel of VTP is in its simplicity. It's so easy to go in there and change the VTP domain name to match that you can end up replacing your entire VLAN database. That's its Achilles heel. But that when you go into your switch, let me do a show VTP status. That's your key show command to remember. It's going to have a domain name that's there by default. Now, this is the default. It's null, literally blank. So I can go in there and type in VTP domain name, or VTP domain. Yeah, okay, there we go. VTP domain, and we'll do CBT nuggets. right? Now, it says changing VTP domain name to CBT Nuggets. I'll hit the up arrow and show the VTP status. It must match exactly the same. Case does count. So capital, lowercase matters between those two. Likewise, if you decide to go in and do a VTP password and type that in, that obviously case sensitive has to match on both sides as well. You now know how to troubleshoot trunks and VTP. I hope this has been informative for you, and I'd like to thank you for viewing.